Humanity has always expanded outward. From crossing oceans to orbiting Earth, every major leap forward began with a simple idea: survival through exploration. Today, that same instinct is pushing us toward Mars, not as a flag-planting mission, not as a short scientific visit, but as the first attempt to build a permanent human city on another planet. SpaceX is leading this effort with a goal that sounds almost unreal: establishing a self-sustaining civilization on Mars within this century. Elon Musk has repeatedly stated that Mars must eventually support over 1 million people, producing its own food, energy, oxygen and fuel, independent of Earth. This isn't science fiction. It's an engineering problem on a planetary scale. The foundation of this plan is Starship. Starship is not just a rocket. It's a fully reusable interplanetary transport system designed to carry over 100 tons of cargo or hundreds of passengers in a single launch. Unlike previous spacecraft, Starship is built to land vertically on Mars, refuel on the surface, and fly again. That capability changes everything. Without reusability, building a city on Mars would be financially impossible. But rockets alone don't create civilizations. Mars is hostile in ways Earth never was. The atmosphere is less than 1% as thick as Earth's. Surface temperatures average around -60 degrees Celsius. There is no global magnetic field to block radiation. Liquid water cannot exist on the surface, and the planet is constantly exposed to solar and cosmic radiation. A human standing outside without protection would lose consciousness in seconds. Because of this, SpaceX's Mars strategy begins without people. The first missions will carry autonomous robots, cargo, power systems, and mining equipment. Tesla's humanoid Optimus robots are expected to play a major role. These machines are being designed to perform physical labor in dangerous environments, operate tools, move cargo, and assist in construction. On Mars, robots will scout terrain, assemble solar farms, deploy communication networks, and begin extracting water from underground ice. Water is the single most important resource on Mars, not just for drinking, but for oxygen, fuel, and radiation shielding. Orbital surveys and rover missions have already confirmed large subsurface ice deposits, especially in regions like Arcadia Planitia near Mars's equator. This area offers relatively flat terrain, moderate temperatures, and accessible ice, making it one of SpaceX's likely settlement locations. The oxygen supports human life. The hydrogen becomes rocket fuel, but SpaceX doesn't plan to use pure hydrogen. Starship runs on methane. Methane is easier to store, safer to handle, and far more practical for long-term operations. Mars provides the missing ingredient through its carbon dioxide-rich atmosphere. Using a chemical process called the Sabatier reaction, hydrogen from water combines with carbon dioxide from the air to produce methane and oxygen. This allows starships to be refueled on Mars. Without this capability, every return trip would require fuel brought from Earth, making Mars settlement impossible. In situ fuel production is the backbone of the entire plan. Once water extraction and fuel production are operational, human missions begin. Early crews will be small: engineers, doctors, biologists, and construction specialists. They'll live inside Starship initially, which doubles as temporary housing. Starship's stainless steel structure provides basic radiation protection, and its pressurized interior supports life for months at a time. But Starship is not a city. Permanent habitats come next. Early Mars homes won't look like glass domes from science fiction movies. Transparent structures provide little radiation protection and would be extremely difficult to manufacture on Mars. Instead, the first habitats will likely be inflatable modules brought from Earth and then buried under Martian soil or ice for shielding. Several research groups, including NASA, are exploring ice-based habitats. These use water ice as structural material, forming thick, translucent shells that block radiation while allowing natural light to pass through. Ice is abundant, self-healing, and one of the best radiation shields known. Other habitats will use Martian regolith, the planet's dusty surface material, mixed with binders to form concrete-like structures. Experiments have shown that regolith can be turned into durable building blocks using heat or chemical additives. Even human waste products can be processed into binding agents, creating what's called biocrete. On Mars, nothing is wasted. Every molecule matters. Power comes primarily from solar energy at first. Massive solar arrays will be deployed by robots, paired with Tesla megapack battery systems for overnight storage. Mars days are nearly the same length as Earth's, but global dust storms can last for weeks, sometimes blocking sunlight entirely. Because of this, future settlements will also rely on nuclear reactors, providing consistent baseline power regardless of weather. Electricity supports everything: oxygen generation, water recycling, heating systems, communications, agriculture, and manufacturing. Food is one of the hardest challenges. Martian soil contains perchlorates, toxic compounds that inhibit plant growth. Crops cannot simply be planted in native dirt. Instead, early farming will rely on hydroponic and aeroponic systems, growing plants in nutrient-rich water under controlled lighting. These systems recycle nearly all moisture, using LED lighting that's, optimized for plant growth. Human waste is processed into fertilizer. The carbon dioxide exhaled by settlers actually feeds the plants, while the oxygen produced by crops, in turn, feeds the settlers. It really becomes a closed-loop biological system. Over time, industrial processing facilities may detoxify Martian soil, allowing larger-scale agriculture. But for many years, Mars farming will look more like vertical indoor gardens than traditional fields. Everything on Mars must be recycled. Water is filtered endlessly, air is scrubbed and reused, and organic waste becomes fertilizer. Even packaging materials are repurposed into tools or building components. A Mars city just cannot afford inefficiency. Early manufacturing will focus on essential parts: replacement tools, structural elements, plumbing components, electronics housings. Metal extracted from Martian rocks can be refined for construction, and three-dimensional printers will fabricate custom parts on demand. This ability to manufacture locally is what, really transforms a research base into a city. So, transportation evolves next. At first, folks move between modules through these pressurized tunnels. Later on, enclosed electric rovers start connecting different neighborhoods. Landing zones get paved using sintered regolith, to prevent all those pesky dust clouds during arrivals and departures. After that, warehouses, medical centers, research labs, and communal spaces begin to pop up. Population, it grows slowly. Each launch window between Earth and Mars comes around roughly every 26 months. During these windows, fleets of starships set out from Earth, carrying new settlers and their cargo. Early on, arrivals are just in the dozens, then hundreds, then thousands, eventually tens of thousands. SpaceX, for their part, envisions hundreds of starships arriving during each window, all building toward a population of 1 million over several decades. But, survival alone just isn't enough. For a city to truly thrive, it needs culture, education, governance, and a sense of purpose. Children will, eventually, be born on Mars. Schools will teach engineering right alongside planetary science. Doctors will focus on low-gravity medicine. Architects will design spaces that are optimized for human psychology in these confined environments. Artists will, of course, create a Mars-specific culture. Laws will have to evolve to suit a world where resources are finite and cooperation is, absolutely mandatory. Mars gravity is only 38% of Earth's. The long-term effects on human health, honestly, still remain uncertain. Colonists might never return to Earth due to bone density loss and cardiovascular changes. This makes Mars settlement not just migration, but really divergence. So, the ultimate goal here is self-sufficiency. Mars, must be able to survive even if Earth just stops sending ships altogether. That means, well, independent energy, food, manufacturing, medicine, and governance. SpaceX, for example, estimates this would require at least 1 million residents, and honestly, decades of infrastructure buildup. It's not about escaping Earth. It's about ensuring that human civilization doesn't exist on only one fragile planet. Natural disasters, pandemics, asteroid impacts, or even human conflict could, all threaten life on Earth. A thriving Mars city acts as a backup of civilization itself. This is why SpaceX pushes so aggressively toward Mars, not because it's easy, because it's necessary. Building a city on Mars will be the hardest engineering project humanity has ever attempted. It will demand breakthroughs in robotics, energy, biology, materials science, and spaceflight. There will be failures, there will be setbacks. Ships will crash, systems will break, people will struggle. But every civilization begins in harsh conditions. Earth's first cities formed in deserts, floodplains, and frozen landscapes. Mars is simply the next frontier. And if SpaceX succeeds, future generations won't look back at Mars as an impossible dream. They'll see it as the moment humanity stopped being confined to one world and started becoming a truly interplanetary species.